As you see here, the problem is asking us to change A, B, C, D, E, F to F, E, D, C, B, A. The position of the letters. And it's asking for the minimum number of swaps. And it's basically like a board game. What is the minimum number of moves or swaps to get to the final destination? And as you here, that kind of helps us. We have an example as well. They give you an example, ABC to CBA, 3 swaps required. And in this example, we actually see a really helpful strategy. So we have ABC, and it's saying that it takes 3 swaps to change it to CBA. So A has to move all the way up, has to move into the last position, B has to move left of it, and C has to be the letter that's in the leftmost position. So A has to move in between B and C, and then move to the rightmost position, to the last position. So we have ABC. A has to go over here. It takes 2 moves because it first goes in between B and C, and then after that it moves right of C. Okay, so now we have BCA, and then we now move B into the position between A and C to achieve what we want, CBA. And we have 2 plus 1 is equal to 3 moves. And this kind of helps us with the framework of this problem. So we have 6 letters now, but A, we still have the same destination. We want it to move to the rightmost position or the last position of where, like basically where F is right now. And so that will take one in between. The first move will move A in between B and C. The second will do move A between C and D. The third will move A between D and F, and the fourth move would be in between E and F, and then all the way to the final position. So as you see here, this is the first move. Each U, upside down U, is 1 move. And then we see that there's 5 moves total for A to move into that position. So we have now rearranged our letters into this. Now, the second letter that we want to move to the rightmost position is not rightmost position, just left of A, is B. So B has to move between C and D. B then has to move between D and E, E and F, and then F and A. That's 4 moves. And again, we're taking the most optimal path, the minimum number of swaps, because we are making sure that B doesn't go backwards or B doesn't go like a stop, in between in the middle. That won't help us. So yeah, so B is now right here. So now it's A, B on in the 2 positions that they need to be in. And then we have D, E, and F still in that position. And C. You can't forget C. Okay. So C again has to move. Let me write this clear. C again has to move like B, but just 1 less step in between D and E, and then in between E and F, and then in between F and B. So that's 3 moves. And then we can keep on going for all the successive terms, subsequent terms, D, E, and F, and then we get the answer. We get the answer 15. So the answer to this problem is D.